harder simultaneous equation problems. I'll cover a concentration or a mixture problem and a distance speed time problem. How many litres of 30% acid solution and how many litres of 60% acid solution must be mixed to produce 18 litres of 50% solution? Alright, always look at the question and see what are they asking for. How many litres of 30%? How many litres of 60%? That tells me that when I allocate my variables, let x equal the number of litres of 30% solution and y will be the number of litres of 50% solution. Because that's what they asked for, so that's what I want as my variables. Now, our relationships. Well, x plus y is 18. First equation is nice and easy. But it can be a little bit tricky to spot the second equation. The key is using your percentage as a decimal to write the second equation as just the amount of acid, or whatever the thing is that you're mixing. So 30% of x will be acid. As a decimal, that's 0.3x. 60% of y, so as a decimal, that's 0.6y. And that will equal the amount of acid in the final solution, which is 0.5 because it's 50% of 18. So my equation becomes 0.3x plus 0.6y is 9. And since I had to do working, I usually like to, if I've got time, restate my final equations. Oops, equals 18 Now for this, it's a bit of a toss-up whether you'd want to do substitution or elimination. Substitution, you could rearrange this to be in terms of x or y, or elimination, I'd probably just get this to be 0.3x. So I'm going to do equation 1 times 0.3, which will give me a new equation, equation 3, 0.3x plus 0.3y equals 0.3 times 18. We might grab a calculator. 5.4. Okay, and then we could subtract equation 2 minus equation 3. Yep, that will work. Say what we're doing. 0.3x minus 0.3x cancels out. 0.6y minus 0.3y gives me 0.3y. 9 minus 5.4 is 3.6. And y is 3.6 divided by 0.3, y is 12. Y was the number of litres of 60% solution. Use this equation. Substitute y into equation 1. X plus y is 18. X plus 12 is 18. So x equals 6. And because it was a word question asking for the number of litres of each solution, you have to painstakingly write therefore. What do we need? 6 litres of 30% acid solution and 12 litres of 60% acid solution must be mixed. So the wording of my answer comes from the wording of my question: how many litres of 30% acid solution and how many litres of 60% acid solution must be mixed? So I'm being very careful to give a word answer that exactly answers that. Next question. A train passes Deb's house travelling at 80 kilometres per hour. 2 hours later, another train going the same direction passed at as fast a speed. 110. How far away from Deb's house will the second train pass the first train? Now, these can be a little bit tricky. If I'm attacking them, I tend to remind myself over in a corner somewhere, speed is distance divided by time. Time is distance divided by speed, and distance is speed times time. I usually just start with that in my mind. And then you look at what they're asking for. How far away from Deb's house will the second train pass the first train? They're asking me for distance. So my first variable is going to be distance. And the key point here is that if one train passes the first train, when we find that point, they are at equal distances from Deb's house. So D is the distance travelled, and it's the same for both trains. Then we'll have to choose another variable. And we know speed, so there's no point choosing that. So you'd choose time. And let T equal, now they travel different amounts of time, but you know the relationship between the time they took. The fast train took 2 hours less than the slow train. So you pretty much just have to state T is the time of the fast train or the slow train, whichever one you choose, and it doesn't matter because it will work out either way. I'm going to use the slow train. There we go. Now, there can often be a temptation to use the speed, since they gave us the speed, and it would work. I usually find I often have a false start with one equation before I work out what I want to do. The key thing to remember is that whatever that distance is, it's the same for each train, and I find it easier to remember that I should be setting up an equation for what I want to find. I want to find the distance. I'll use the equation for the distance. So, for the slow train, distance is speed times time, and distance, the speed was 80 for the slow train, and that's times time. Then for the fast train, distance was speed times time, the speed was 110, and the time was the same time as the slow train minus 2 hours. So instead of being fooled into thinking that the times, well, there's time of one and time of the other, remember that you know the relationship between the time of one and the time of the other, so you can represent them both times in terms of t. And that gives me a pair of simultaneous equations. I will substitute 1 into 2. And then I will expand and solve for time. So I will subtract 110 from both sides. That will give me negative 30t equals negative 220. T equals... Now sometimes you're better off using fractions. Ignore the negatives because it's both negative. So if I did 220 over 30, 22 over 3, some questions will aim for fractions. With time and distance, I'd prefer using a decimal, especially because here 7.3 recurring is 7 hours and 1/3 of an hour, which is 20 minutes. But we're not actually looking for time, we are looking for distance. So now that we know speed and time for one train, substitute t equals 7.3 recurring into equation 1 or 2, but equation 1's easier. Equation 1. Distance is 80 times 7.3 recurring. Now you'll see I took it back to a decimal. It's nice and neat to have the time in hours and minutes, but then when I need to be doing my calculations, I would have to change this back into a decimal anyway, so we might as well have a decimal. And I've got a decimal here, so I just need to do multiply by 80. And distance was 586 and 2/3 kilometres, or 586.67, or whatever we would prefer. And that was the distance away from Deb's house at which the trains would pass. Therefore, I'll call it 587 kilometres from Deb's house.